Hello everyone. In this video we will discuss about the reactions of alkene. So what kind of reactions they do. This is pretty easy. So you will see questions like this in exams in your homework. What's gonna happen if you add hydrogens or if you do a certain reactions in uh, in alkene? What is the product? So find the product. So you will see questions like this. Okay, so the first reactions we gonna look at today is hydrogenations. It is pretty easy things to figure out. So it is called hydrogenations because we are adding hydrogens. So that's it. We are adding hydrogens. Okay, so let's see. I'm gonna color code this so that you will see the difference. Okay, let's start with the easiest one. So let's say we have C double bond C and then we have hydrogen. So what is the name of this one? This is, we have two carbon atoms, so that's eth, and then this is a double bond, so that's ethene. So what's gonna happen if we add hydrogen to this molecule? So what is hydrogen? Hydrogen is gas, and hydrogen gas is made up of two hydrogen atoms, right? So it's made up of two hydrogen atoms. So it's called, so when you do this reactions, you have to do this reaction in presence of catalyst. So usually catalysts are either one of this metal. It could be platinum, it could be nickel, sometimes it could be palladium. So either one of this metal is there, platinum, nickel, or palladium. So you have those metal and you pass the hydrogen gas. So these are catalysts. So what is the product is going to be? So what's going to happen is the double bond is very reactive towards this hydrogen. So it's going to go from double bond to single bond. So here is what's going to happen. So you're going to break the double bond. So it's going to be C single bond H. So look what I did here. I break the double bond and that double bond is now converted into up here. I'm going to color code H and H. So those two hydrogen from the hydrogen molecule, the red hydrogens, it comes here. And where did it go? It goes to each individual carbon atom that was in our double bond. So look here, the carbon atom here has four bonds, 1, 2, 3, 4, and here it also has four bonds. So carbon atom always gonna have four bonds. So what this did was it add hydrogen. So if you notice, if you heard about the hydrogenated oil, a lot of the oils has alkene bonds in them. So double bond C, double bond C. So the hydrogenated oil, so when we do hydrogenase them, add hydrogen, it's gonna make those double bond into single bond right here. So what is the name of this molecule would be? So it still has two carbon atoms, so it's still at eth, but it's now all single bond. So if it is all single bond, what is the suffix? It's gonna end with a and e, so it becomes ethane, right? Ethene, you start with ethene, then you made ethane. All right, so let's do another quick example. So here's the questions for you. What is the product if you react 2-pentene with hydrogen in presence of nickel? So nickel is the catalyst. So first thing that you want to do in this problem is draw the structure of 2-pentene. So pent means how many carbon atom? 5. So let's do the skeleton. So I'm gonna do C. I'm leaving a space for hydrogen. C. So it's got 5 carbon atoms. So where exactly the double bond? At the location 2. So this is 1, 2. So I'm gonna add the double bond here. And now let's add the hydrogen. So look at the carbon. This carbon atom has already one bond, so it needs 3 more. So H3. This carbon atom has 1, 2, 3 bonds around it. So to make it 4, it needs 1 hydrogen. This one has 1, 2, 3, so it needs 1 more. This one has 1, 2, so it needs 2 more, CH2, and the last one needs CH3. Okay, so if you do this and react with hydrogen in presence of nickel, what would you get? So I'm gonna color code again. So let's color code this like this, H and H. So the product is pretty simple. All you have to do is bring these two right here and you add to each one of them. So all I'm doing is I'm writing the hydrogen right beside it, well, right under it, and I'm making this new bond. That's all you have to do. So you have to break the red double bond here and attach this one there. So what is the product is going to be? CH3, CH, CH, CH2, CH3. So we're gonna add hydrogen, hydrogen here, and that's all. So the double bond is gone. Now it becomes single bond. So this is for demonstration purposes. Then what you can do is instead of writing CH like this, you can delete this and make CH2, CH2. Easy. All right, so what's the name of this one? It becomes pent, A-N-E, pentane. So it went from alkene to alkane. All right. Okay, so we're gonna use the exact same principle for our future reactions. So next reactions is hydrations. So hydrations, we get hydrated, right? So hydrations means adding water. So you just dump some water to your alkene. So let's start with the simpler one. CH2, CH2, and this is what is it? Ethene, right? 2 carbon atom, ethene. Okay, so we're gonna add water. So remember, water is made up of hydrogen and oxygen. If you want to write like this, or if you want to write like this, OH. So water is made up of hydroxide and hydrogen, right? So OH and H. So all you are doing is, so you are breaking, you are just write down the water right below the alkene, right below the double bond. So what you're doing is you're breaking one of this bond and you're attaching C to the O and C to the H. That's pretty much what is happening. So what would be the product if you make here? So it should look like this: CH2, CH2, and OH. Okay, let's not worry about the name. This is a different class of compound which we will study in the next chapter. Let's not worry about the name, but this is what's going to happen. So let me quickly recap. This was your alkene was given to you, and you add water. And when you add water, you just write the water right below it, connect one of the carbon to oxygen, and connect the one to the hydrogen, and that's pretty much what happened. So that's what you made, CH2OH. You don't have to write like this. You can write like this, straightforward: OH, CH2, CH3. All right, so make sure everybody has 4. This is where everybody does mistakes. I do too. Like, I don't count the hydrogen sometimes. So 3 hydrogen, 1 bond, so that's 4. 2 hydrogen, 1 bond, 1 bond there, so that's 4. And oxygen can always make 2 bonds, so 1 here and 1 with hydrogen. All right, okay, so let's do another quick example. This is where this is the complicated example. Next example was, let's say, propene. Propene was CH3, CH, double bond, CH2, and you add water to it. So what would you make? So let's color code. OH. So water is H2O, right? So it's OH and H. Okay. So now, because in this, the above example, it was the alkene was symmetric, both sides are equal, so it doesn't really matter. But this is a asymmetric alkene. So this is asymmetric because why it's asymmetric? Because the double bond on the left side of the double bond is different than the right side of the double bond. So it's asymmetric. So this location is asymmetric. So you have two scenarios. You can make two products. So this is where a little bit you have to be careful. So let me see. Let me explain why you're gonna get two product. So I can attach my carbon like this. So let's color code this. Let's connect this here. Let's connect this here. So let's see what we get. We got CH3, C, CH, single bond, CH2. So we got this OH and H. So this is option one. So let's call this option one. However, since this is asymmetric, you have another options. So it could go like this. CH3, CH, double bond CH2. So now the water, so oxygen could go to the other carbon atom. So now the center one could go for the hydrogen and the outside would go for the oxygen. So what is the product you'll be making? CH3, CH. Oh, we forgot the color code. CH3, CH. So always remember the double bond is always gonna be gone and it's gonna convert it into single bond. And but the question is, which one is correct? So there are two possibilities. The OH could go to the right or the OH could go to the left. So here is the rule. Well, there is a principle behind it. There is a theory behind it, but this theory would be out of scope. You will learn that in the future. Why one of them happens in the majority of the time, the other one does not. That's a little bit out of the scope of this course. But so let's follow the rule. So the true answer is gonna be this one, and I will explain the rule. So if you have two scenarios like this, you attach the hydrogen to the carbon atom that has already more hydrogens. So let me write this one down. So this is not possible. So let's delete this and write down the rule. So rule is hydrogen will go. So this is called Markovnikov's rule. Hopefully I pronounced this correctly. Markovnikov's rule. Okay, so hydrogen will go towards the carbon atom that has already more hydrogens. So I know this is not a good example, but I like to, when I was in school, I like to remember in the world of capitalism, the rich gets richer, right? So let's look at here. So the carbon atom on the right side has, this one has 2 hydrogen and this one has 1 hydrogen. So the carbon atom that has 2 hydrogens, that would get even more hydrogens. So now that one is gonna get more hydrogens, and obviously the other side would be OH. So that's how I remembered when I was in school. So in the world of capitalism, the rich always gets richer. This is a bad way to memorize, but that's okay. Okay, let's do another quick example. Let's say we have 2 pentene plus water. So what is the product? So this is another example. Okay, I'm gonna keep the rule here. So it's kind of pretty easy. So let's draw the pentene first. So let's draw C, 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 C. 2 pentene, so the double bond is on the second carbon atom, 1 2, which is here. So let's add hydrogen, so it's going to be CH3. This one, 1 2 3, need one more, 1 2 3, need one more, 1 2, need two more, 1 2 3, three more. All right, so we're gonna add water to it. So we're gonna add water to it. So when you add water, you're gonna add across the double bond. So what is the rule? The rule is find the number of carbon atom that has more number of hydrogen. Well, this example doesn't work out pretty good. Let's change to 1 pentene. My bad. Okay, let's change to 1 pentene. Then it will be a little bit more obvious. So let's change to CH2, double bond, CH, and CH2. Okay, let's remove the color code. Okay, so how are you going to add water? So first thing that you want to do is find the double bond. So this double bond is here. Find how many carbon atom each carbon atom has, how many hydrogen atoms. So this one has 2 hydrogens, this one has 1 hydrogen. So which one is bigger? This is bigger. So when you add water, the hydrogen would go towards the carbon atom that has already more hydrogen. So in this case, the hydrogen would go there, and this would go here. So what would be the answer? So answer would be CH2, CH. Nothing else changes on the other side. So we add H here and OH here. So just make sure everybody has 4. So this one has 1 2 3, and the 4th one is hydrogen, so that is good. This one is 1 2 4, so nothing changes here. Let's look at here. This one has 1 2 and 2 hydrogen, so that one also has 4. So that is the answers. Well, if you want to write it a little bit better, then instead of writing hydrogen like this, you can write CH3. All right. Okay, so the rule is hydrogen will go towards the carbon atom that has already more hydrogens if you have asymmetric alkene. All right, let's stop here.